Hi everyone. Thank you for joining today. My name's Phil, and what we're going to be showing you today is my journey into platform engineering, how I experimented with some of the tech that we're going to look at today, about delivering a hackathon at the Access Group. So, a little bit about myself. I'm really a software architect that's kind of turned into a platform architect. I love automating things.
Can you
I
hear
love
me now? Yeah.
anything to do with technology.
You've got one.
I've been looking at platform engineering for 3 or 4 years now and really, really loving all the innovations that come with it. And I'm learning as I go. I didn't know Kubernetes last year that well, and now I get to talk about what Kubernetes is and how to use it. So if you know nothing about Kubernetes, don't worry. All you need today is just your internet. I have a really good mantra that I love living by. There's no right or wrong way. There's always a better way. And I take that everywhere I go. If I'm looking at code, looking at problems in production, or even how our platform should evolve, it's always, when we do decisions and they go, what happened there? Well, we can always make it better. And of course, I'm joined by the wonderful Abby. So tell us about yourself, Abby.
Yeah, hi everyone. So I've also been in technology for a similar amount of time as Phil, and the biggest overriding thing is I've been in internal tooling, and for the vast majority of that time, started in different roles. I've been in QA and DevOps and SRE, but basically my entire career has been about how to help my fellow colleagues make better software, make it safer, make it faster, make it more efficient. So that is why I find myself, I think, at Syntasa, where we're building Kratix, which is a framework for helping platform engineers build internal platforms for their organizations. And we're going to be using that a bit today. If I haven't run into you yet, I hope I do soon. I'm all around the community. I'm in the CNCF Ambassador program and doing a bunch of work there. Team topologies advocate. I love that socio-technical combination and just in general around meetups and trying to meet people online and learn from people. So please come say hi. And I am not as mantra driven as Phil, but he really puts me on the spot. And I think what I think about a lot is that it's great to stand for things more than against. And I think that comes true in technology a lot, where there's so many people who can hate certain programming languages or certain IDEs or certain technologies, but really where the power comes from is being excited about something you really love and pushing that forward and giving that oxygen. So in this platform engineering space with all of its things going on, find the things you love and figure out how to invest in those, would be my advice.
Do you know, I've just realized both of our mantras are feel good, lovey, looking forward mantras. So
Very
it's
us,
really
very
cool. So
us.
that's very us, very us. So yeah, I mean, the one thing about for hackathons or even platforms in general is to try and make things as easy as possible. I've built a few platforms internally within Access, and I've learnt some things. Some engineers love Terraform, some like customizing it, but it's those guardrails. If you put the hands of the Terraform into the engineers, where's your where can you look in and say, well, please don't add an app gateway here because that mucks up our network topology, etc., etc. So, we found that by designing, we wanted to really design a platform where you could self-serve. You didn't need to know all the technical ins and outs of what Kubernetes is or even GitOps. You just want to be productive, right? And that's all we're doing in platform engineering, finding ways of how to make your engineers more productive. So what about Access? Who are we? Well, we are the largest UK headquartered software company. We have offices all around the globe. And I started just as a developer in our health and social care division about 8 years ago now. So I'm really grateful for opportunity and of the growth, and I've loved watching Access grow. We used to have 800 people when I started. We now have just 2,600 engineers alone within the entire group, with around 10,000 employees. So just that growth in 8 years is a massive undertaking. You can imagine the technical challenges when we're thinking about platforms, how we implement things. Again, it's all very social technical. How are people doing things today? How can we make you better? We provide solutions across all quite a wide range of industries, from healthcare to human resources to factory and warehouse management and even ticketing systems. if you've done a job hunt recently, our software is so impactful you might not realize where you use it. If you've done a job hunt recently, you've probably used one of our 20,000 recruitment businesses that use our screening software to manage interviews and place and pay even temporary workers. We're in schools as well. So if you've got kids at school in the UK and you charge and top up their lunches or their dinner money, that probably goes through our software. There's so many places that where our brands add value to everyone's day to day that we just want to make life a little bit easier and give our customers and ultimately their users the freedom to do more. But I could talk to you about Access forever. I love what I do, I love the company, and I love the way that we can network and work with brilliant people like Abby. But we're here to hack, right, Abby?
Heck
So
yes.
let's just get into it, shall we?
All right, so we're going to get your hands on keyboards right away. There's going to be some talking, there's going to be some chatting about what we're doing here, but we want to treat this like a true workshop and not just a talk that's been extended. So you'll see a bit.ly link there. Let's get that pasted into the chat, why don't we? So that is there you go. So you can go into that link and that will boot up an Instruct box. So Instruct is an online web-based platform for being able to get involved in technology. And they've been fantastic about supporting the community and supporting us. So hopefully this will all work really well. You don't have to download anything on your computer and just let us know how that goes. Uh, Thank you, Rachel, as well for a clickable link. I appreciate that. So the thing that we're going to be working on today is the hackathon, and what Phil does great is just be cool, calm, collected because he has truly made things usable. Because this is his example. He did he did this hackathon, and I don't know if I can. How do I there? Oop, I might have gone one too many back. There we go. This was Phil. This was Phil on vacation, serving 200. What was it 250 engineers, Phil, on this
Yep,
workshop? Yeah,
250
that's hackathon.
projects. Yeah, like
250 projects.
I
Yeah.
was. It was once in a lifetime holiday with my grandparents, right? They're in their mid 70s, and this was me watching the hackathon kick off while I had enjoyed a bottle of rum. So I felt great. If I can make you guys look like this on every hackathon and your day-to operations, I'm a happy man.
Awesome. So, with that, what we're going to do is go through the first couple sections together. So, I've got the same thing you should be seeing here open in my browser. So, hopefully, what you've seen is a start button there that you can click. And I think it will ask you for name and email as you go in. And what's going to happen is in the bottom right corner, we're going to get a green start button in just a second. So, that should happen fairly quickly. I'm surprised that's taking a second. It must mean that we have a lot of people in the room because we've warmed up a few boxes. There we go. So if you press that start button, this first kind of task is just getting to know Instruct. So this is a platform you may not have seen before, and we want to make sure that it doesn't get in your way. It's here to help you, not get confusing. So I'm just going to show you around for a second. So when you open this up, you can see that you can open and close these tabs and navigate the instructions. When you see an image in the instructions, you can zoom in on them by clicking on the image, and then clicking back off the image will make it disappear. So you should be able to navigate to the information that you most want to see. You'll also see that there's some tabs here in the top that you can navigate between, and there's going to be slightly different tabs for each task that you do because we want to make sure that we stay focused. But you'll always have access to the things that you need when you need them. And the last tab, this feedback tab, is always available where you can give feedback to us about this workshop and we can make sure to make it better and better for people. It will be available for you and your friends and colleagues afterwards if you're interested in it. So if we can make it better for you in the future, that's what we want to do. So once you have read through this and you feel comfortable with Instruct, you can click this bottom right corner of check. And what that's going to do is progress you to the next task. The next task is where we really get to jump into the platform engineering, and we're going to introduce you to your first experience with something as a service via Kratix and the Kubernetes API. So again, we'll get a little green start button in the bottom right corner when we're ready to go. And again, we can use the instructions on the right to be able to navigate and do the project on the left. And so the way that the rest of this workshop is going to go is that we're going to give you some time to self-learn with this text. It's really hard to do that when someone's talking at you. So we're going to give you 5 minutes to go through the text to going through that, getting understanding of it. And then what we're going to do is we're going to run through it, being able to answer any questions, give any kind of color commentary associated with this as you're kind of finishing up with the task, and then talk a little bit about why it matters, and then we'll move on to the next. And you can see that we're going to do that 5 or 6 times today as we build up in complexity from a first service to a full hackathon.
Mm.
So yeah, and just to warn you that like if you click check before when you're done, you may get a warning that things aren't ready. That's because Phil and I are going to control the timeline for people as they go. So if you do get done in faster than those 5 minutes, we will unlock everybody to go to the next stage when you're ready. I see we're getting some issues with the links, but it seems like people were getting thumbs up, so that's good. Glad you're getting in, James.
Thank you, everyone.
And thank you everyone for sharing those links over again. That's very helpful as we're trying to manage the different stuff. Any questions on that, or else what I'm going to do is stop talking and let you all loose on instruct and hopefully
Mm.
creating your first services successfully. But so what we're going to do now is I'm going to actually run through this. So again, just to talk through what's going on here, as well as be able to give space for any questions. So please throw them into the chat. Please do unmute, turn on cameras, whatever you feel comfortable with. I just want to make sure that we both just want to make sure you get your questions answered, because that's why we're here to do this with you live. So this first section is all about providing something as a service. And as platform engineers, we should and often do try and take things from the toolboxes of the community around us as much as possible. And so the first thing that we do here is we use the marketplace from Kratix to provide Postgres as a service. So by running a kubectl command here of applying a Postgres promise, what we're doing is we as platform engineers are installing Postgres into the Kratix service that we're running. We teach Kratix about how to use Postgres, and that includes both setting up an API for end users to make requests to, that's a CRD, and setting up any dependencies that API will require to be able to create instances. And in this case, we're depending on a community operator that manages Postgres in Kubernetes. So we're deploying that operator to anywhere that the Postgres might be provided. And this is all based on Kubernetes objects, but Kratix is the kind of plumbing or the framework that supports that end-to-end journey of something as a service. And so providing something as a service is about providing somewhere for people to make on-demand and self-service requests. That's the API. That's this number one in this image. Then something that customizes each request to the point where it actually is bespoke to the business, but also bespoke to the request and meets all the compliance and requirements of the business. That's number two in the workflows. And it depends on a set of things, which we talked about, like that operator, which is number four in the image. And both the dependencies and the workflows actually can be kind of API calls, or Kratix provides a GitOps as a first class concern. And so can write things into a state store. So a Git repository or an S3 bucket or a lookalike of either of those. And those can be then applied in a declarative way, in a GitOps way. So this is just sort of a diagram around what promises are and how they work. With that promise installed, we can see that this specific promise has its API and has some workflows. So again, we're just seeing that shape of what a promise custom resource definition looks like. And the specific custom resource for Postgres can be viewed in YAML as well. If you're not super comfortable in Vim or in the terminal, we will be opening up this promise in an IDE in a later section. So if you want to explore promises and the YAML behind them, but you're not super comfortable in this terminal, don't stress, you'll get a chance to have a look at that. So this promise has been installed in Kubernetes, which means that we can see information about it by querying the Kubernetes API. And so in specific, sorry, I think I scrolled a bit much here. In specific, we can see that the CRD has been installed along with all the other resource types in the cluster. And so here we've got Postgres. Postgres is here. There it is. There it is. Postgres from the marketplace have been installed, and that means that requests can come in. And the specification for that CRD is described here. So when people make requests, they can decide if they have backups enabled. They can provide database names, environment variables, what namespace and team ID things should be deployed into. The final piece of this, so that's all talking about how people make requests to something provided as a service via Kratix. But Kratix also does all the plumbing of how to actually make that, realize that into reality, to make that real. And that's the dependencies. So when this promise was installed, Kratix was told that these operators need to exist for this to be provided as a service. The way that Kratix manages that is it schedules that workload to any of the applicable parts of your infrastructure. And that could be Kubernetes. It is in this case, but it could be virtual machines. It could be edge computes, serverless functions. It could be mainframes we have people running in. So it doesn't matter where this is. It's all Kratix can orchestrate any of that infrastructure. And we can see that that has been declared using a workflow. So this workflow is running in the Kubernetes, the Kratix platform service namespace, and resulted in a commit into Git. So git t admin and the password here. So remember, this is all GitOps as a first class concern. So these are all of the YAMLs that are now going to be deployed across your estate that matches where Postgres should be allowed to be deployed. And those YAMLs, the operator and the CRDs and all those things can now be viewed on, you can see the worker cluster. That's that worker context. We've got the operator set up and ready to go. So at the end of this section, what we have is we've taught Kratix what it means to provide Postgres as a service in this context. And so Kratix is ready to provide these as a service to your users in an automated way. So it's on demand and self-service. Why that's important is because, no, don't go back to playing that video. Why that's important is because this as a service methodology is what makes platform engineering and makes platform engineers high leverage engineers within an organization. Because to a lot of people, platform engineering almost feels backwards. They've been through that transition from dev and ops being separated and are like, we love DevOps. We want autonomy. We want no delay. We want no friction. We want teams to be able to do what they need to do. And platform engineering is re-centralizing everything. So it all feels a bit backwards to some people. And it's fair enough because there's a reason why DevOps became such an important part of, delivering software. But the thing is platform engineering is re-centralizing because what we've learned is that at scale, DevOps becomes almost impossible due to cost. Can you get a security expert in every team in your organization? Sure, if you've got a handful of teams, but as soon as you get to tens, hundreds, or even thousands of teams, that's just not viable. It also becomes not cost effective because each team is recreating the wheel. So we want to become an economy of scale within our own organizations, and we want to re-centralize. But we can do that using team topologies methodology, which allows us to centralize without increasing delays because we provide things as a service. We can centralize by making sure that autonomy is still provided while the critical pieces to safety and compliance are included. And that when we make it so easy for people to create things, that we also make it equally as easy for them to maintain things. And this is done through centralizing the idea of providing services without centralizing control over creation of those services. And that's platform democracy. You can check that out in the QR code in the bottom right corner. So I do see a couple of questions. So is the code available so you can host your own hackathons? Phil, I think our code is So this workshop can be made available in code, and I think we can possibly even put something together that's just the end result. I don't know if we have that though right now, so worth
Uh,
doing after this though.
yeah,
That's
worth
a great
checking. I'm
question.
sure we can
Yeah.
publish it on GitHub somewhere. But
Yeah.
what I did for the hack is use mostly the marketplace and what we're going to do today. So we'll show you the patterns, and hopefully that gives you the creative freedom to go, oh, I use Istio. Let me use an Istio ingress rather than an Nginx ingress, right? So it's really customizable to your needs.
Yeah. Cool. So Scott, we'll get on that. At the very least, you can reuse this box, and you'll probably be able to steal the code that you need because it's just a bunch of YAMLs from this box if you want to do that. But we'll try and get you something more usable.
Yeah, and
Uh,
feel free to reach out to the community as well, Scott. So the Syntasso community, Slack community is quite active. I'm in there, so feel free to reach out and ask me a question there too.
cool. Also have a question about orchestrating the entire process for spinning up services on demand. So we what we've done so far is just provide the ability to create a service on demand, but we're about to go see what it looks like to actually create an instance of that service on demand. And you can automate as much of this or as little as you want. At the end of the day, it's creating Kubernetes objects. So if you have ways of running that through your automation, you can do that. And that sort of goes as well for you, Anthony, about the creating promises through other mechanisms. So yes, we've talked about creating libraries for creating promises. We use Gemini through Google, also to use AI for generating these promises. But at the end of the day, they're Kubernetes objects. So anything you use to make Kubernetes objects. So Pulumi is an example of that. And there's a few others that you can kind of create Kubernetes objects through more testable like languages. You can do for promises. So there's nothing unique about the promise in the kind of Kubernetes landscape. So
And I use the Kratix CLI to stand up quite a lot of my
yes,
promises. So today we're showing you Kubernetes because that's what I did in the hack. But in fact, where I use Kratix today is to orchestrate my Terraform, which the CLI can help with. So it really can orchestrate anything. What is your end goal? You design your system around that.
cool. Well, that's enough about me. We are going to go on to the next section. So what you're going to do now is unlock yourself by creating a file on the machine. So you can use the touch command to create that file. And you are currently in the home/KubeCon directory if you haven't moved around at all. And so you can just create it in the local directory or use the complete command to say home KubeCon as a service. And once you've created that file, you'll be able to recheck. So in that bottom right corner, click the green check button, and then that will succeed, and you'll move on to the next section. So we've cheated a bit. We've given ourselves all the files so that we wouldn't have to try and type live. There's enough live coding here for us for one day. And so, as I said, when you click check, that should go through and check. That's being a bit slower than I was expecting, to be fair. Are other people having? Oh, there it goes. Cool. And you can click next. And so you can continue on to the self-service. So what you've been doing is the platform engineering experience. Now you will be doing the application developer experience and see what that feels like.
So
And then we'll
you've gone through, hopefully you've had a go through this basic self-service, and what we've created, what you've been able to see is by installing this operator and defining the APIs, how we can go and consume those APIs as app developers. So hopefully you've gone through this and seen that you've got your promises ready and available. And we're going to go and request a simple database using that API. We're going to use the dev environment and all the other fields ready to go. That's going to schedule a request, go through Kratix's controller, and write out to the destination of our worker cluster to be reconciled. We can see this and how it's performing by checking out all of our PostgreSQLs. And we can see we've got a status here that our example request, is what we've named it, has got 1 GB, is version 16, and it's got no backups. We can check the workflows. Now, every promise request that goes in through Kratix is its own job with its own set of workflow. So each request has its own pipeline. And we can watch that hopefully and see on the worker cluster here that we've got our Postgres server created. So hopefully that answered your question in the chat as well, to see how we've taken the operator, the request, and say, here's the setup. But now we're going, hey, let's make our app dev teams more productive. It's really important to see how it gets scheduled, right? You've seen the magic of how it is interfaced in kubectl, but let's have a look at Gitty, see how it's actually written that out. If you go into Gitty, you can go into the worker cluster folder, check resources, and you'll notice that there's an example instance configuration with our YAML that we've put here. Now, this looks very, very different to the API we've given to you on the teams. You might see here this marketplace, we're only asking for dev, team ID, and DB name. But there's a lot of decisions that we as platform teams have made for this request. And that's really the power of deciding your level of control. Do you want a promise that has all the API endpoints for the configurations you need? So you give the teams ultimate flexibility, but it's really complex. What decisions do they need to make on number of replicas? Is it backed up? What are the organizational policies? Or do you want a really tight API that's relatively small, that doesn't have a lot of configurability, but is easy to get started? You're not increasing the cognitive load of so many settings. The Postgres promise is a fantastic example of this. In our promise, and you can go and have a look at this, we'll see it in the next file, is if you say in the environment on the API, if it's production, we as platform engineers will make the decision that if it's in production, yes, you are going to be backed up. And I think you'll need a little bit more than 1 GB. And we want it to be relatively HA with 3 replicas. That will change ultimately the output of what gets scheduled to the worker cluster. But all the end users had to think about is, am I dev or am I prod? That's really the power of abstracting these APIs and make it easy for our teams to interact with us. So to continue on to the next section, you can go ahead and put in this touch command for on demand, but maybe you can skip ahead. So
Yeah.
let's see if you can skip ahead, but we'll leave it up here leave it up here too. So the next section is, I think it's app as a service. I think this is my favorite part. This is about bringing two things together. Um, would you want a fruit bowl or a fruit salad? You've got a database, but we're going to need an app on top of it as well. How do we compose these things together?
Great. Welcome back. I'm going to run through this now section with and for you to talk it through. So, as Phil mentioned, it's fruit salad versus fruit bowl. Do you pre-prepare things or do you provide them as complete services? Um, or like higher levels of abstraction. So in this case, what we're saying is that it's not uncommon to ask an operations team for a database to connect to your web app, but then you're as a person running between those two things. This is all about, as a platform team, providing an abstraction that takes in those pieces and configures them together for the engineer. And so what we can see is that there's now a couple promises on the in the Kratix instance. So there's not only the Postgres that was introduced in the last sections, but there's also an Nginx ingress and an app promise. And that's because inside of the application promise, so we can make a request to that higher level kind of application to get that moving. The reason why we have these different promises is because if we go to the editor, I promise you could see a promise YAML in an editor. You can see that there are required promises here around Postgres and Nginx. So it makes sure that we get those installed and usable by this app as a promise. And the app as a promise isn't recreating what Postgres and Nginx means, it's using them. So at the end of this request for an app, I'm making actually a request for an Nginx configuration and a Postgres
Mhm.
instance and making sure those can speak to each other, which will result in and that's all being done through GitOps. And that will result in an application actually being made available in the browser. And so you'll start with seeing a 502 because it's not yet deployed. But if you wait a minute or so, you will get to the point of your to-do list being loaded up and having that Postgres behind it. And at the end of the day, this is all still going to be cataloged in your platform because the platform is in Kubernetes and Kubernetes provides listing as a first class concern. So we have now a catalog of applications on the platform by just using kubectl. And we can view that in any other uh, kind of tool, which we'll get a preview of in an upcoming section. So at the end of the day, what this promise did is it was what we call a compound promise. It ran a workflow that resulted in requests to multiple other promises that are more fine-grained and generated those requests. Those went back into the platform cluster to then run through their workflows of those promises, which then resulted in the infrastructure and resources on the worker cluster. So it's really just using the same mechanisms, but doing so at a higher level of abstraction. And at the end of the day, you can go see the underlying Postgres's for it. So you can see the to-do DB, and you can see the resources on the worker cluster along with the database information, like the access to secrets and permissions and things like that. Now, the value behind this kind of example is to think about the fact that platforms are software. Software has this challenge of too big, too small, and just right. If you ever grew up with the three bears, right? And there's always debates over should you use monolithic or microservice. If you're doing microservice, what's the right domain shape and size for that service? And as software, platforms can learn a lot from software architecture conversations. We can use the same heuristics to decide how big something should be or how small it should be, how they should interact with each other, how to keep them independent. And so having a look at what software does should be applied to the software behind your platform. And if there's one thing that we know from software application sizing is that you're never going to get it right. Sorry, that's the jumping forward, but as much as you might try to design the perfectly shaped and sized service, it will be too big, it will be too small eventually as your domain changes and as your information at hand changes, and you'll want to update it. So really great software provides you the ability to compose and decompose as you learn more about how it should be shaped. And so what you saw here was the ability to compose a higher level of abstraction to an application, like persistent application, without having to redefine the lower level pieces. And we should be able to do the same thing where if we learned that if we had started at application level and realized we need to break out databases as its own service, you should be able to decompose. And anything you're using to do platform engineering should have these capabilities because they need to be flexible and they need to have standardization across all use cases of that software instead of just copy and pasting, which creates drift and hard maintenance. So you can check out Gregor Hope's book on fruit basket or fruit salad via this QR code and via his book. He's great. So we're going to jump from the composing section by using the compose password if the passwords are still necessary for you, and into the next section, which is going to be all about, I think, customizing our platform, because we know that a platform is all about making something that is bespoke for your business, because if you can buy it, you should.
So you have gone through how to customize, hopefully customize your app as a service. So this is exactly what I got to, right? I can deploy an app. I learned what compound promises are, what that composition is, but I need to I need to add some more information to it, make my applications more usable. So one way to do that is adding environment variables to our API. We all need environment variables in one way or another to control actions, give a bit of configuration, etc., etc. Now, of course, this is a hack. We wouldn't obviously recommend you doing this the right way with secrets, but this is a great way to get you started. I'm sure in your own implementations, in your own organizations, you would follow all the great best practices. But this is local, so have fun. All we've done so far, the first thing is to have a look at our Promise API, and we're going to extend it with an environment field. We have quite kindly given you some scripts to copy and paste, so no manipulating files and worrying about YAML. And that there is just added that into the spec, which you can go check by either going into the editor tab. And if you've seen this and gone, where is it? Just remember to hit refresh and that will reload the file from the disk. And we can go apply this change to our platform. We can then go validate that the platform has understood that change and it's been applied. And we see here's environment, the environment variables for the container. Now in our to-do app, we have two environment variables we can set. We can set the version to an arbitrary number, so feel free to experiment with that. But we've also got an enterprise version of the to-do app if you wish to deploy that. So give a go, have an experiment. So you've seen this, we've gone through, we've created the app, we've added a version for it. We're going to wait and see what happens. Now, when we go and check this first, you might realize at this stage, okay, I've got my to do, but the environment variables, you haven't done anything with them. Well, it's because in our promise, we haven't extended the workflow to do anything with it. We're going to add that into our workflow file here with a YAML. And then now with that information, we're going to update that promise. So before the first step is let Kratix be aware of the new field. Now we're implementing that field to go do something. And you see there that third or fourth one, we're just waiting for that to finish and it's completed. Now, if I go and have a look at my example UI, hooray, I've got version 1.12.1, which is what I set. This is great. I am able to, this is, as I said, keep saying this is exactly where I got to on my journey. I got environment variables. What's next? Well, it's adding value to our engineers. What's the best way? Let's give them an interface to interact with. So we use this same app as a service to deploy our instance of Backstage the same way engineers were going to deploy their hacks. We were really eating our dog food. So we were able to run 250 projects with across three hackathons across various areas of the business, and we customized it to our needs. We used a Let's Encrypt SSL certificate, which meant we changed the ingress configuration that we were outputting. And we made some other changes in our system to make it work really, really nicely. So with that, we can move on to looking at the next layer and see how we can go even further and use that Backstage interface to do something cool.
There we go. All right, welcome back. What we have just been doing is actual platform engineering, right? What is platform engineering if it doesn't include some JavaScript? Wait, that sounds wrong.
What?
I don't know.
No
Okay.
JavaScript, please.
But what we've been doing is getting that portal view, right? So this is where that idea of an IDP gets sometimes a bit confused between internal developer platform versus internal developer portal. I don't really mind what you call things as long as we talk about UIs and APIs. So here we are adding a UI on top of our API. So we've got a Backstage instance. We can enter that instance and we can see that we don't have any promises there. Using Kratix, because Kratix orchestrates really anything you want in containers. We're having a great chat in the chat about Ansible and Terraform and cloud providers. It can orchestrate anything. It can also orchestrate creating your portal for you. So get yourself away from JavaScript and just focus on generating the API. The way we do that in using the enterprise plugin is to just add a label. And now this can be done in the open source with writing your own translation layer between a CRD and Backstage. And we actually have a version of this workshop where you can do that as well. But in order to get things a little bit faster, we ran out of time last time. We're going to use the label format on this one. And what that label does is it kicks off a controller that is running in the cluster and generates components for Backstage. And those components are both components that are made visible in the catalog, as you can see here, as well as a template for that API. So now all of a sudden, users can create things through the API, like we were doing before, through kubectl, or through this portal being Backstage. And we have connections to a bunch of the portals, Port, Cortex, etc. So anything that can get automated or declaratively set up can get done using a workflow. So now the experience all of a sudden improves for people, right? Is that we can go in and we can create a, oh, this is still set up for our last time we ran through this. Sorry, Phil, my bad. Uh,
That's okay.
but we can create a KubeCon um, app, and we can ask for our Postgres instance, and we can, not need to set any environment variables, but set a version 2.0 image. Um, we can call this again KubeCon. I could have updated it there while I was typing, but I didn't. Uh, and make our request. And now that request is going to go into the terminal. And so if I do a kubectl get pods and watch them, I can actually see that workflow running here, right? So it's running right alongside the to-doer one. You now are
Mm,
seeing the KubeCon one because these are all just requests to the same backend services.
mm,
Um, What's really interesting about this running is that it is not just a create and forget, which is what how Backstage works by default with templates. Kratix also comes with a plugin which allows you to go look at the KubeCon app and actually manage it. So you can come in and you can edit editable fields. So some of these fields might be editable, some may not be, and that's configurable through the platform. So we saw, you can't change the name of the request, but you can change whether or not you have a database, whether or not you have environment
mhm,
variables and things. And you can also delete that request. What you allow your users to do should be something you set up in your API, and it will then get
mm,
translated into this UI. So if you don't want people being able to delete things, you turn off delete. That's okay. This is just configuration of what people can do at the API level available to you at the UI level. Uh, One thing also to note is that request went directly to kubectl from Backstage, which is a very common pattern in the Backstage world. But you can also configure this to go to a GitOps repository and be managed that way. So again, whatever your principles are, the key to building your platform is being able to do it on your own terms. And the Kratix framework sort of lets that, enables that and encourages it. Okay, so with that, we've got now a real platform, right? Because we've got Backstage. That's what I hear. Uh, and I, but I want to talk about like why it was important to bring in Backstage, but also why it was important to make sure that we prioritize the API first. And that's because the API is your baseline interface. It is an interface. It just might not be the one your users want to use. So you can always provide more on top of it. But when you're thinking about interfaces your users want to have, you have to think about what they want. Sometimes it is a portal because they want that ability to navigate a website. Their interface needs to be low skill oriented, very easy to navigate. But sometimes what they want is something really close to them, contextually close to them. And so they want something in their IDE, like they want an IDE plugin. You can see if you join the Kratix Slack, we've had a user recently put out an IDE plugin for Kratix. Those are the types of things that developers may want as well.
I mean, I
But
fell in love, so yeah, I'm all for it.
exactly. So what you want to do is think about what kind of interfaces you need or want and make sure that you are not doubling, tripling, quadrupling your workload by having to configure things in each interface. Prioritize your API, let your interfaces come on top of it. And this slide actually comes from a talk that I gave with Whitney Lee, who's just amazing, at KubeCon Paris at the Platform Engineering Day. And really, the best way to remember this is that your API is a pig. Come on, get it? A pig? API pig.
Yeah, I
Yeah,
mean,
it's got so the
I get
inter
it. I get it. You got to tar up your APIs, right? But
exactly.
it kind of works in the software development space really well.
Exactly. Like they do need some lipstick. I'm not saying
Yeah.
APIs are the only interface you want to provide, but they are your baseline interface. So if you want to check out that talk, that's that QR code. But that is the essence of the talk. And with that, we are on to, I believe, our last section, which is great timing. So you can use the touch command with a pig to continue on. And you will be figuring out how to manage all of these resources that now your users have started to create because there's been no friction for them to create them. And that can sometimes create a maintenance headache, but we're going to go and see what it looks like to fleet manage them.
So, you've had a look at fleet management. Has anyone got a platform at the moment and think how would they do that in their own? Because that's what's bugged me, and that's what I really love about Kratix. In previous platforms I've written that are Terraform driven, if I have to go update them, spreadsheets, project management, and all the reasons why they can't do it. That's the cool thing about fleet management, right? I can take the requirements of the business as a platform engineer, codify them, and take that choice at a business level, not at an implementation detail for the engineers. So you've had a look and seen that you've got a load of apps, but they're running with a replica of one. We know that's not going to be highly available. What if I cut a cable or remove a hard drive from a node or it fails? Let's try and balance that out. All we're going to do is to change the specification that gets written out to the scheduled destination. That might sound like a lot of word soup, but remember, every target GitOps repo in Kratix is a destination. So let's go and add that into this promise. And you see here, we're just changing the replica to 2, which is amazing. And again, we don't have to tell our engineers, go redeploy your application, go rerun that pipeline. No, we're the platform guys. We're going to do that for you and apply that promise. As Kratix knows what the state of that promise is, it's going to recognize and say, hey, something has changed to the specification and I already have some resource requests. Kratix is going to run through each of those resource requests and update them with the new output. So you see at the top here, we've got the platform here running all of the different areas, and slowly and surely they're going through updating all the replicas. Let's see that in a bit more of a tighter way. So if we check here, all the replicas, as we'd expect, are set to 2. You can do that with anything with Kratix. So you need to change your ingress. You need to go, we're using Istio now, or Calico, or insert technology name here. You can really think about offering things as part of your platform as hidden services. Think of observability. That's a really good one. Observability should be core of your platform. Why should engineers need to choose that? You can make that decision and see here how you can really improve their day-to-day workflow. And that's it. That's what takes you to hackathon readiness. So the next section here is your free for all. Go play, go delete files, RMRF root, whatever you need to do. But I just want to talk you through a little bit about the power of GitOps. I've made some mistakes, right? I've told you that I haven't learned, I don't know this stuff last year, and I am an IDE boy. I like looking at things and clicking buttons, and sometimes that gets me into really tricky situations, like it did last year. So I was looking at an error in my open lens and going, "Hey, I just want to get rid of this error. I didn't know what it was doing. Remove." I clicked that button and all of the pods on my worker cluster stopped working. Everything deallocated, but the Git repo was still there. So I was a little bit unsure what happened. I'm going to tell you now, don't click that button ever. But a quick little call to both to the team at Syntasso, with Colin and Derek. They were like, Phil, you've just deleted the customize, re-add that in, and everything comes back up. Now, this also destroyed our Postgres database because we weren't doing backups as a hack. But thankfully, my friend Andre, who is my front end architect, really encouraged me to take a backup. Even though I was like, no, the platform will be fine. He was like, Phil, please can you take a backup? I will feel better for it. And I'm eternally grateful for it.
And next time you'll test that backup.
Yeah, next time I will, right? Right. So backups are becoming a design feature. They're a feature now, not an afterthought. But it's cool, right? GitOps and the power of the abstraction of Kratix is making us rethink about how do we manage fleets of Kubernetes clusters at scale. With these destinations, we can have multiple clusters reconcile from the same file. So we can do active passive, active active. There's a whole wide variety of architectural choices that we can make based off our availability requirements. So in conclusion, you have a hackathon today. You could use this today to go build a hack, but my final architecture looked a little bit like this. I had Backstage, cool an app template, app as a service template, which did a little bit more. It did some code generation in .NET or React and pushed that to an Azure DevOps pipeline. The Azure DevOps repo. The Azure DevOps repo included a pipeline that would build and push the container, but also do a kubectl apply against the platform cluster to register the request. Now I cheated a little bit. I didn't know about how to do CI/CD into Kubernetes clusters, and I didn't really want teams to constantly have to change a file. So I cheated. I made it easy, right? Platform engineering, make devs' lives easier. So I used an operator called QoSH that was listening on a webhook for whenever a new image was arriving. It would trigger that webhook, find the deployment, and then bump the image for me automatically. So it was really, really good fun. And we had no issues. The biggest issue we had is I can't run the hack code on my machine, which is great for a hackathon, right? The platform worked and we had some fantastic feedback and looked at we even ran a survey as well, which was fantastic. Now, I'm here presenting, but I am one person. I couldn't have done this without my team and also some fantastic influential people that have helped me get this far. So Adam Lonsdale is a fantastic engineer that's really helped build out quite a lot of the hackathon areas. Andre, who I've mentioned, David, Justin, Stefan, all people within the organization or outside the organization that have helped. And of course, the Syntasso team are great at listening to all sorts of challenges and really do understand what their tool is a framework. Every time I say, I want to do this thing, it's based off what I need to achieve. What is the objective I need to go solve? And I think that's the power of a framework. It is transparent. I can go do what I need to achieve. So in summary, Abby, where should we go from this?
In summary, I first want to just call out the great work you did of using a hackathon to be doing app and platform experimentation, right? You were trying to figure out how do I build out this platform? You did that with a hackathon, and we can use that in that way, and it was great. The second thing, though, is that you were planning on how to get started quickly. But I, knowing you, it surprises me, but you were very thoughtful of saying, yes, a hackathon is fun for a day, but I want a platform for years.
Yeah.
So how do we make this thing something that will be sustainable over time? And so you got started quickly, but with a vision towards how to get things fleet managed over time and yeah, being sustainable. And the last thing I want to call out is that what we were building here was like a three-tier architecture because as I said earlier, platforms are just software. You have display layers like portals, you have middleware layers like Kratix, and you have backend infrastructure like GitOps delivery through Flux or other infrastructure as code. And Kubernetes makes for a great tool when it comes to that middleware layer, and that's why Kratix is built on top of it. So that is sort of where we got to today. There's been a couple of really interesting questions in the chat. So I encourage if you haven't looked in there to have a look, but I want to call attention to one or two. So first of all, as we're wrapping up this tutorial, yes, there will be written instructions. There are written instructions, and there will be a video of this available. Um, and oop, go back.
Oops, sorry.
We're both going. Go straight to the end, Phil. You'll be all good. So we're gonna share this slide deck. It has all these links in it. Come follow us on the socials. Find us in the platform engineering Slack channels or CNCF Slack channels or Kratix Slack channels, any of those, and we'll be able to share this stuff with you, and we'll share it out. But secondly, we have a question about how do you do this in a mature platform? So Kratix is being used by some of the largest companies in the world and being used in kind of brownfield environments because it can orchestrate anything. But what does it do with the things that already exist? That is still part of infrastructure as code and operations. How do you adopt software today? If your software is done through ClickOps, you can use adoption tools that are provided by the Terraform community, the Crossplane community, the Pulumi community to adopt those into infrastructure as code. Once in infrastructure as code, the mechanisms to get it into a promise become a lot easier. And the way that I've been working through this with one of our users is we've been scanning basically for consistency across their resources, figuring out what is standard already versus what is unique currently. And what we've been doing is taking those standard things, building those into the promise workflows, those things where we're seeing uniquenesses across their infrastructure, building those into API fields that are optional. And then we are working towards creating standards up the stack through higher levels of abstraction because they're not happy with how many things are not standard. And that's really what Kratix does is, or any platform orchestration, is it highlights to you where you can do better in the way of standardization, compliance, and helping people move faster and more efficiently. So, yeah, so adoption wise, first of all, you're going to want it into infrastructure as code where possible. So using the tools that exist to get there. Then you're going to want to do create your workflows off the back of that, and that's going to depend on looking at what is unique to your different API uses and what isn't. So, for example, scanning all your S3 buckets and figuring out what fields are unique and need to be part of the Promise API because there are uniquenesses in your organization. So hopefully that was concrete enough for that answer. The other question was around like kind of upgrades, but I just realized we're out of time. So check out the chat there. Come find us on the Slack. We're happy to answer questions. Come find us on social media, anywhere that you can find us. Let's have a chat. So thank you so much for staying engaged for a whole 90 minutes. I know it's a long time of attention these days. And we'll make sure that you get access to the box, the instruct, as well as all the instructions in the video as they become available. So thank you so much for all of your time.
Thank you, everyone. Have a great day, and I'll see you all soon.